I think you've seen this one before. Here's the first enzyme in glycolysis, hexokinase, attacking a glucose molecule. The glucose molecule comes in, and the enzyme sort of has a partially formed active site that it can drop into. But as it docks, the protein changes shape. Presumably it's also pushing and pulling on bonds in the substrate. But clearly the enzyme is different in the ES complex compared to a free enzyme. It's wrapping around that substrate. So that wrapping around moves the catalytic residues in place to do this chemical attack and strains the substrate to adopt a transition state. So this final point on the bottom there is saying X-ray structures show when people do a detailed analysis of most enzymes, there's some kind of movement like that on substrate binding. The substrate binding induces a change in the shape of most enzymes following this reduced fit hypothesis. That's just another view of it. Okay, let's finish off by talking about regulation. So again, not all enzymes do any kind of regulation, but many do. And we'll talk about 3 different kinds. The word allosteric has already come up. That's a very common mechanism where you have another potential binding site for a regulatory molecule to come in. Post-translational modification is where something comes in and puts a group on the enzyme, like a phosphate group, covalently attached to either activate or inhibit the enzyme. And then some enzymes are activated in a special one-time way. They're called zymogens. And let's start with the zymogens. Zymogens, like the digestive enzymes in our stomach and in our small intestine, those are all made as inactive precursors that are pumped out into the stomach or into the GI tract as inactive proteins. They're inactive because they carry some stuff that must be clipped off. So the activation of them happens by cleavage, trimming off little bits here and there. This is an irreversible event. It's a one-time activation. They come in with no activity. You put them, chop them up, trim them to final condition, and then they're active forever. You can't shut them off again.